Okay, so today we'll be doing new lesson. Today's lesson will be Born-Haber cycle. Okay, Born-Haber cycle, it's a method where you calculate lattice energy. Basically, okay, that's the one. Okay, the one that you study His law. His law that use the vector thing and so on that we study here is being used to calculate the lattice energy. Okay, what is definition for lattice energy? If we are using His law to calculate lattice energy, then we call it Born-Haber cycle. Itu maksud dia. Okay, so we have to know the definition for lattice energy first. We studied this in term 1. In a solid sodium chloride, strong ionic compound hold the Na plus and Cl negative ions together. Can you see here? Energy required to break the ionic bond and separate the ions, Na plus Cl negative solid, can you see solid here, become Na plus gas plus Cl negative gas. Delta H is positive 770 kJ per mole. Okay. Thus, they say when Na plus Cl negative ion comes together to form a solid chloride, sodium chloride, the same amount of energy must be released. Okay, and they join together, energy release. Na plus gas plus Cl negative gas gives you Na plus Cl negative solid. Delta H is negative 77 kJ per mole. This is what we call as lattice energy. So definition is what? This one write down. Jangan pula PKPD and so on. You don't write the notes. The lattice energy of an ionic compound is the heat release when 1 mole of solid ion is formed from its constituent gaseous ion under standard condition. Okay, solid you get the product, gaseous ion is the reactant under STP. Okay, example here, lattice energy for potassium chloride is negative 701. Always release energy, that means it's exothermic. Negative 701 kJ per mole. So write a thermochemical equation. That this is how you write down. Don't forget the state of matter must inform here gas, and solid. Okay. K plus Cl negative tak tulis pun tak apa. Yang important thing is there must be a solid here. Okay, example. Another example there. Question. Sodium bromide. Sodium bromide is NaBr. So they ask you to write down the thermochemical equation. How do you write down? Na positive gas plus Br negative gas gives you NaBr solid. Inilah dia. Delta H negative 742. So this will be the answer. Got it? Okay. Okay. So definition for lattice energy done. Now we look at factors affecting lattice energy. This one they might ask you first part of structure questions, okay, before they move on with the calculation part. Because in this chapter they prefer more on calculation. Okay, factors affecting lattice energy. Lattice energy is measured of strength of the ionic bonds in the ionic solid. The stronger the ionic bond, the more exothermic is the lattice energy. Okay, lattice energy depends on what? Charge of the ions. Charge. So when you compare Na plus and Mg2 plus, between Na plus and Mg2 plus, so obviously Mg2 plus will have higher charge lah. Okay, Mg2 plus higher charge. And then another one is size of the ion. So these are the two things, lattice energy. Actually I've done it before. Higher the charge of the ions, the stronger the attraction between the ions. Hold it together. Okay, how easy for it to stuck together, what make it strong. So similarly to people, okay, stronger like gravity. So the higher the charge, the stronger will be the bonding. So Mg, when you compare with Br, Mg and Na plus, obviously Mg will pull Br negative much more stronger. Okay, simple logic, because Mg is stronger charge. Okay, another one is size. Smaller the size, the shorter the distance between the ions. This will increase the force of attraction between the ions. So meaning to say, size smaller, okay, size smaller, charge higher. This will give you one higher value for lattice energy. Size smaller, charge higher. Okay, that's how we compare. So example here we have NaCl, Na2BO, MgO, Al2. Okay, so the first one they're comparing here NaCl dengan Na2O. So between these two fellas, why do you think the charge for delta H for the Na2O, delta H here, lattice energy for Na2O is stronger, higher there, negative 2000 something, yet for NaCl is just negative 770. Why? Then simple logic, the charge for the anion is much more bigger for O, so O can hold the husband compared to Cl negative. Charge for Cl negative just negative 1 saja. not strong enough. Okay, here we are comparing the size, second part of it. Semua Na, husband dia sama, cuma Cl saja, the charge also the same. So here you cannot say the charge, different charge. You have to talk about the size. So Cl negative, Br negative, I negative. Who can hold the husband stronger? Look at the size. Normally the cute girlfriend, the small thin one will hold the husband there. Cl negative. See the ionic radius. Just 181 compared to I so fat one cannot hold the husband. So the bigger the size, the weaker will be the attraction force. So the lattice energy will be smaller. See, this one smaller compared to Cl negative. Okay, so that will be the size. So quick check 7.8, they ask you to compare, suggest which one is more exothermic. So between MgO dengan MgCl negative, Mg don't compare lah. We compare O dengan Cl2, and O, as you can see here, O is negative 2, whereas Cl is negative 1. So straight away go to the charge. Bigger charge, hold the husband stronger. Okay, and then for the case of BaSO4 and MgSO4 and BaSO4, you don't compare the charge, because charge for this group are the same. This one pun positive 2, this one also negative 2, this one also positive 2, this one also negative 2, so no point. The one you're supposed to compare is the size, Mg and Ba. A simple way to compare size, look at the nuclear number. Okay, right.